Maintain and repair automation and control systems of main propulsion and auxiliary machinery. Temperature sensors. The temperature sensor is sometimes known as a transducer that converts heat energy to proportional electrical signals. The temperature sensor is an important instrument used on board to measure process value and to ensure that plant is working satisfactorily. In this video, we will discuss the various type of temperature sensors used on board ship and their application. Thermistor, RTD, resistance temperature detector. Thermocouple. Thermistor. A thermistor is a sensitive transducer whose electrical properties like resistance vary as per temperature. In other words, it's thermally controlled resistor. A thermistor is a sensitive semiconductor metal oxides whose resistance increases or decreases in temperature. Based on increase and decrease in resistance, thermistor is classified as PTC or positive temperature coefficient. Thermistors are those whose resistance increases with an increase in temperature. NTC or negative temperature coefficient thermistor are those whose resistance decreases with an increase in temperature. For temperature measurements, thermistor is placed in the Wheatstone bridge network under balanced conditions. There is no flow of current in the midpoint of the network, that is, P1 and P2, since the potential drop is the same at two ends. When the temperature further lowers, there is a change in resistance. The bridge unbalanced, there is a voltage drop across P1 and P2. This voltage further amplified converted to digital data using ADC, analog digital converter. Thermistors are used on board ship in motor winding temperature measurements. In the fire alarm system, it is used in some heat detectors. RTD, resistance temperature detector. RTD is similar to a thermistor. Instead of semiconductor, metallic resistance wire is used as a sensing element. The sensing element is small turns of resistance wire forming coil, is placed inside the ceramic enclosure. The resistance wire is free to expand and contract as temperature changes, minimizing error caused by a mechanical strain. The air gap is filled with magnesium oxide powder, which provides better heat transfer from ceramic, thermowell, to the coil. The commonly used component as resistance wire, sensing element, are platinum, PT, nickel, Ni, and copper, Cu. Platinum is highly used because it has the highest temperature range, stability, and corrosion resistive. Popularly used platinum RTD are part 100. The name PT100 is because at OOC resistance is IW ohms. Pint 100 is commonly used temperature sensor on board ship. Almost all machineries like main engine, generators, tank monitoring system, etc. use PT100 sensor. The sensing resistance of the element used in a part 100 sensor increases with an increase in temperature. See a chart that describes temperature versus resistance relation. Thermocouples. Thermocouple is a device which is widely used as a pyrometer on board ship for continuous measurement of temperature for various machineries like main engine, auxiliary engine, gas turbines, etc. It is absolutely important to choose the correct thermocouple material for different temperature range operation depending upon the machinery and thermocouple location where the parameter has to be measured. Construction of thermocouple. A thermocouple consists of two dissimilar homogeneous materials connected together. The materials used depend upon the application and usage. Normally, following materials are used for different temperature range. Copper. Constantan. Copper nickel alloy for range of -200 to 400 degrees Celsius. Iron. Constantan for temperature range of -40 to +750 degrees Celsius. Chrome. Alumal. Alloy of nickel, manganese, aluminum and silicon. For temperature range of -200 to +1350 degrees Celsius. These materials are connected together in a ceramic sheath, covered again by a metal sheath and fitted at desired locations like exhaust manifold, etc. The one end of the thermocouple is placed in hot junction, and other end is kept in a constant cold junction. These materials are led to a temperature indicator through amplifier and compensator lead. The amplifier and compensator lead, normally made up of copper and does not affect the circuit, helps in transmitting the output to a remote location. Principle and working. Thermocouple works with the principle of Seebeck effect, which states that temperature between two dissimilar metals in a circuit converts into electric current. When two dissimilar metal wires joined, suppose iron and constantan, are coupled together and exposed to difference in temperature at both the ends, then EMF is generated and current flows from hot to cold side. The magnitude of the current depends on the temperature difference between the junctions. If one junction is kept at constant temperature, then the value of temperature for the other junction can be easily determined. Advantages of thermocouple. Can be used for remote temperature sensing. It can be used for continuous temperature sensing. Temperature difference can be measured with high accuracy. They are inexpensive and easily interchangeable.